Morning. My name is Kevin Myers. I'm a network architect with ArchiTechs, and we're going to talk a little bit this morning about ISP operations. I normally do a lot of things in design, so I decided to do something different and actually talk about troubleshooting and fixing things that are broken and things like that instead of talking about design. So we're going to talk a little bit about OSPF for IPv4 and IPv6 this morning. So first of all, let me tell you just a little bit about myself. I've spent about 20 years networking now. I got involved in networking and IT in the late 90s. We are global in what we do. We've designed and built networks on 6 continents. The only one we haven't touched is Antarctica. I'm a MikroTik certified trainer and hold certifications from MikroTik, Cisco, and Microsoft. One of the things that I'm very passionate about and that I like to do is be involved in the networking community and in a bunch of different network communities. And a lot of you out there in the crowd I interact with on Facebook and some other mediums, MikroTik forums and things like that. One of the things I'm involved with is packet pushers. I've been a podcast guest on there as well as a blogger on packet pushers. If you know those guys, a great networking resource. If you've never seen it, I'd highly recommend it. The RouterOS and Wisp Talk Facebook groups, if you're not involved in those, you should definitely check them out. There's a wealth of information out there. If you want to know about networking, Wisp networking, and things like that, go check out those groups. Network Field Day, which is an interesting scenario where they take you out to Silicon Valley and go to places like Cisco and Juniper and all these Silicon Valley companies, and they kind of show you the next generation of networking. So I've been involved in that, and we talk about what networking will look like in the future. The MikroTik forums, obviously, you can find me there, and Network Collective, which is another podcast that's fantastic. If you want deep-level network engineering detail, I highly recommend that you go check that out. And then before we get into it, I'm going to tell you just a little bit about what I do, what ArchiTechs does. We are a global consulting firm. I think at this point we're the largest MikroTik consulting firm in the world. We've got offices in 5 countries. We've got engineers that speak more than 6 languages, and on any given day, we've got about 20 or 30 projects spanning the globe in different time zones. So we do a lot of stuff with white box, ISP networks, data center networks, enterprise. We do work for enterprises of various sizes, from small ones all the way to publicly traded Fortune 500 companies, things like that. So if you need some consulting or some help with your network, you should give us a shout. All right, so let's talk about the goal of this presentation, what I hope you get out of it. What I hope you're going to get out of it is how to troubleshoot with OSPF beyond just rebooting the router. What are the things you look for when you're having problems with OSPF? What are the common scenarios when OSPF is misbehaving that you want to go look at and see, and what does the data look like? And we're going to look at that mostly in IPv4. I've got a few slides on IPv6 so that you can see how IPv6 is a little bit different and similar to OSPF v4, or v2 rather. And we're going to look at a quick review of common issues and bugs that we know about with OSPF. And then I've got a little chart at the very end of it that is a MikroTik to Cisco translation, so that if you're doing OSPF to another router vendor, you have an idea of what commands you should use and what the config should look like to do an OSPF adjacency and work with that in another vendor. So hopefully you can see this. I always try to make my drawings as large as I can, but they never seem to be quite big enough. This is the lab that we're going to be working with today. This is the lab that I built to kind of go through these troubleshooting scenarios. If you're not familiar with this, this is out of EVE-NG. Show of hands, any of you ever heard of EVE-NG, Emulated Virtual Environment, Next Generation? A couple people. I'm sure a lot of you have heard about GNS3. EVE-NG is something that we've started to use a lot because it's web-based and it allows you to emulate networks. And so I actually have a 2U server in my office that all of my engineers globally use to validate and build networks. And it's fantastic if you want to test something without using your production network as the test bed, which is probably not a great idea. Okay, I'm not going to get terribly into like what OSPF is because we're mainly going to talk about the troubleshooting, but I'm going to do a quick review of what OSPF requires to form an adjacency. So your hello timers have to match, your dead timers have to match, your network type has to match, the interfaces have to be in the same area, and then one that people don't talk about a whole lot and don't see as much is the MTU has to match. That's one that gets a lot of people because you don't see it in this list very often, and if your layer 3 MTU is off, then OSPF's going to have a problem. So let's take a look at what happens when these don't match. So the first scenario that we're going to look at, I've got a section called Basic Troubleshooting Scenarios, then we've got a couple advanced scenarios where we start getting into looking at LSAs, sequence numbers, and things like that. So let's look at what does a hello timer mismatch look like. And I've broken this down into basically, you'll see I've got 3 categories. All the scenarios we look at, we're looking at it in 3 different ways, so you can kind of see where in the router you need to look to understand where you're going to troubleshoot this. So this is a zoom in on the network that we're going to be working with. So you see we've got router 1 down here on the left, and it's got a loopback. You can see the IPv6 is on the same subnet. We've got a /29 transit subnet. And then we've got another loopback of ending in .2 for router 2. So these are the 2 guys that we're going to work with for this scenario. So let's take a look at the config here. So the first thing that I always do when you're troubleshooting is to do a config comparison. Now that's not always practical, but it is easy. So if you're talking about 2 routers that are right next to each other, it's easy enough to go compare config from one to the other. So in this example, we're looking at it and we see that under routing OSPF interfaces, we've got something that was explicitly set that has a dead interval of 1 minute 20 seconds and a hello interval of 20 seconds. So that is different than the default OSPF timers of hello of 10 and dead timer of 40. Now we don't see anything in the export for R2. What does this tell us? Well, that means that that interface was dynamically created when the network statement was put in there, and there's nothing other than the defaults attached to that. So it's a fair bet that these 2 are not going to match. So now let's take a look at actually printing the interface statistics and what that looks like. So you can see similar information, a little bit different format, and this is actually looking at what's running. So the config, one of the reasons I like to differentiate between the 2 of these is there are times when the config that's in the router is not actually what is actioned and running in the router. So you want to make sure that looking at the config is helpful, but you also want to verify, like, what is it actually using? What is it actually doing? And that's what this is for. We're looking at the interface, printing it out. This is the equivalent of a show command for any of you that are using other network vendors and are not familiar with MikroTik. This would be like a show command. And we're going to look and see that we're 20 seconds up here, and we're 10 seconds down here, and that's a mismatch, and that's going to cause a problem. So I've highlighted everything, the odd value in all of these in yellow, and the value that we're looking for in green. So as you see these, you'll see the yellow and green. So now let's look at the log. And this is one of the things that I also see not used as often, is going to the log to try to understand what's happening with the routing protocol. And so one of the things I did in every one of these scenarios was put what does the log message look like when this misbehavior is happening. So if you look, RouterOS tells us very clearly we have a mismatch in hello interval, discarding hello. Now what that means in the realm of OSPF is if the router discards the hello packet, you're never going to get an adjacency. Your routing protocol is never going to come up, routes are not going to work. So if that's where you're at, then you've got a problem, you've got to correct it so that you're not discarding the hello. You can even see it goes further to tell you a little bit more detail. It says, well, I have 20 and the other one is sending me 10. So even if you only have access to one router, let's say you have an outage or a misconfiguration, you can use this log to understand who is the problem child here. Okay, let's go into the next scenario, which is very similar to hello. Same thing, dead timer mismatch. Using the same segment of the network as we were last time. And we're going to look here and see that this time we have our dead timer set to 1 minute and 20 seconds. And same thing here. We have nothing in the export for R2, so that tells us it's using default settings because it was a dynamically created interface. Same scenario. So now we've corrected and we have our hello interval correct, but now we see that our dead interval is 120 seconds, and it's cut off a little bit there on the screen. But our dead interval is 120 seconds, and that's different than this guy. So I'm going to go out on a limb and say that we're going to have a log message that's going to tell us that we've got a problem. And sure enough, you have a mismatch in a dead interval saying mine is 80 seconds and the remote is 40. Now, one interesting thing to note is that the numerical value changes here in the log versus what is set. If you noticed in the setting of the config, it's a minute and 20 seconds. The log puts it as 80 seconds. So those are the kind of little differences you need to watch out for if you're scanning numbers and looking at things. Pay attention to where the way something is represented in the config changes in the way it's represented in the log. All right, so let's move on to scenario number 3, network type mismatch. So there are various network types when you're building an interface in OSPF: point-to-point, point-to-multipoint, broadcast, non-broadcast multi-access, and those have to match in order for it to form an adjacency. So let's take a look at our same network segment that we have here. And let's look at these guys. So in this case, we don't have defaults. We have somebody set the network for point-to-multipoint in this case. But on router 2, they set it for network type NBMA. And NBMA, we're not going to really talk about much, but is a very special kind of network type in OSPF because it does not use multicast. It relies on unicast. The neighbors form a relationship over unicast. I actually see a lot of WISPs will use this as a troubleshooting step. Sometimes radios will mess with the multicast that causes OSPF to work. And so NBMA will sometimes be a troubleshooting step to set the OSPF type to stabilize a link over a point-to-point. Point-to-point RF link, that is, not point-to-point in OSPF. So now let's go into our interface validation and take a look. And sure enough, we are actively using network type point-to-multipoint here on router 1. We are actively using NBMA here. And so just comparing these two can be a huge benefit to you as you're trying to troubleshoot this. And then, of course, if you use your log, you're not going to see a log entry for this issue. And I put this in there on purpose because one of the things that's interesting is that you're not always going to see a log entry for a lot of this stuff. So you may have to go to a packet capture. You may have to go to config comparison. So it's important to understand in RouterOS which issues are going to generate a log entry and which issues are not going to generate a log entry. And if you know generally how that flows and you don't see a log entry but you don't have a neighbor adjacency, you might go back and say, oh, well, it's not working and I don't have a log entry and I know that the network type is one that doesn't generate a log entry. Let me go check that. So as you better understand what condition exists when you have a problem in OSPF for RouterOS, you can kind of start to speed up your troubleshooting. So let's take a look at area mismatch. Same network segment, same IPs. And now we're going to change the OSPF area. And for those of you, I have a blog called stubarea51.net, which is my blog title. And so you'll notice whenever I do network examples for stuff like this, Area 51 is always our OSPF area. And here we've got Area 51 set for the network 203.0.113.128/29. However, on router 2, it's set for backbone, otherwise known as Area 0. And that's what it should be set for, because that's the green one. That's what we want. But it's set for a different area here. So let's see what that looks like here. And I'll give you just a preview. This changes a little bit in IPv6. We're going to look at a couple scenarios in IPv6, and it changes slightly in IPv6 because IPv6 enables OSPF neighbor adjacencies just a little bit differently. And so here you can see the output, the actively used area here is Area 51, just the way it's configured, and backbone here, the way that it's configured. And in this case, the log is actually going to tell you that there's a problem. It says, I'm going to discard the packet because I have a mismatch in my area ID. So it very clearly tells you, I'm configured for .51, but I've received Area 0 backbone, and this is the source of the router that's sending that. This can be a very important piece of troubleshooting information. If you have a very large network, these are the kind of things that you need to key in on when you're looking at a log message. Because if you have 1,000 routers in your network and you're troubleshooting something, that is a piece of information that can be the difference between troubleshooting it for 5 minutes and troubleshooting it for 5 hours. And then we see here in green, this is what we should be getting. Okay, let's look at MTU mismatch. And this is one that also shows up in the log. For some reason, this seems to be a much harder thing to troubleshoot. I see a lot of engineers struggle to troubleshoot MTU mismatch. And this one actually isn't too complicated because RouterOS will tell you when it's having an MTU problem. So same network, same IPs. Only this time we're going to set the MTU here for 1450 explicitly off of Ethernet 1. Now, one thing to distinguish on MTU, because it sometimes gets a little confusing in RouterOS, there are about 3 different kinds of MTUs, base MTUs for interfaces in RouterOS. There's the layer 2 MTU, which is the maximum frame size of an interface. There is the layer 3 MTU, which is not called layer 3 MTU, it's just called MTU. But that is the MTU that's going to be attached to an IP segment. And then you have MPLS MTU, which we're not going to talk about, but that's another type of MTU that's set for if you're going to be dealing with MPLS, label switch traffic. That's a third kind of MTU that's set for interfaces. So make sure you understand the difference between layer 3 MTU and layer 2 MTU because they do make a difference. So we have no MTU config in the export. So like the previous scenarios we talked about, this is going to be set for a default of 1500 at layer 3 because we have nothing explicitly setting it. So now we're going to go through validation. We're going to look at something a little bit different. We were looking at OSPF, prints of OSPF interfaces before. But in this, we're actually going to be looking at an interface print to see where is my MTU. So we can see layer 3 MTU is 1450 here, and layer 3 MTU is 1500 here. And now the log, interestingly enough, is going to tell you two different things here. So in the top one, it's going to say, this is too large. I'm dealing with 1450, and I'm receiving 1500 bytes worth of OSPF information. I can't deal with that. Correspondingly, though, and conversely, it says different MTU, which is a different kind of message. It's saying, I can deal with this. I'm 1500 bytes. I can receive a 1450 byte packet, but I'm going to warn you that this is different than what I'm configured for, and that could be a problem. So these two different, the slight variation in these two log messages can be a clue for you of where you have a problem with MTU. So let's talk about a few more advanced troubleshooting scenarios. This is one that I see all the time, and it's not terribly difficult to troubleshoot, but you have to know what you're looking for. You have to make sure you're using the logs, because if you have a large network, it can be very easy to overlook this. So let's look at duplicate router IDs. Now, we're looking at look at this in two scenarios. We're going to look at this as they're adjacent, and we're going to look at them as non-adjacent. The second one is a really hard one to troubleshoot. I had this issue in a really large WISP not too long ago. It was several hundred towers, and they had a duplicate router ID, but they were not on directly connected routers. One was like 40 routers away from the other one. And so knowing what to look for in the OSPF log is key when you're trying to troubleshoot that scenario. So let's look at the adjacent one first. In the adjacent one, we're looking at this, and that's set in the routing OSPF instance. So here, we have 203.0.113.2, and we've also set it as 203.113.2. So we've misconfigured router 1 to use router 2's router ID. And let's go look at the instance print and verify what it's actually using. And it is using the wrong router ID here and here. So that's going to spit a log message out here for local and remote router ID are the same. So the log is going to very clearly tell you that you've got a problem. Your router IDs are the same. I'm not going to form an adjacency. You're going to have a problem with this. Okay, so this is where it gets really interesting. So we're going to look at duplicate router IDs on non-adjacent routers, and let's see what this looks like. So I opened it up a little bit. We're going to go to all 4 routers, and we're going to have a misconfiguration on router 1 and router 4. And we've got a couple hops in between these guys. So let's see what this looks like. So we've misconfigured router 1 to use router 4's router ID. So it's ending in .4. And then router 4 obviously has got its correct router ID ending in 4. So we go through and validate. Same thing here. It's using .4 when we look at the print of the instance. And we have a .4 here when we look at the print of the instance. Now, here's where it gets really tricky, because it's not going to tell you that what you have is a non-adjacent router ID overlap. What it's going to tell you is that it received an update of a self-originating LSA. So what does that mean? So if you think about LSAs, so LSAs, I'm not going to get into LSAs a whole lot here, but LSAs are what OSPF is founded on. It stands for Link State Advertisement. Every time OSPF exchanges a route with another router, it creates what's called an LSA. The LSA is the information that carries all of those routes that are in your network. The routers exchange them with each other, they put them into the routing database and put them in the routing table, and that's how your OSPF route table is built across the entire network. What this is saying is LSAs carry an ID with them that is specific to the network that's being advertised, because it goes network by network to generate the LSAs, all the different networks that you have. And it generates a sequence number and it generates an LSA ID. So the problem that it's having is the LSA ID that is attached to this is a duplicate of the one that's somewhere else in the network. And if you know what this means, then you can look at this and say, okay, somebody screwed up a router 20 routers away with the same router ID, and I know that because what this is saying is this router thinks it's receiving a routing update from itself. And that's what the self-originating LSA terminology means. And so if you see that log message in there, there's a really good chance that you've got a duplicate router ID somewhere out in the network that you've got to go hunt down. And a lot of times if you do a packet capture or you look in the log and you find the LSA ID, you're going to know what router it is that's misconfigured, and you can track it down because you'll see the networks that it's advertising. And I didn't put it in here because we don't usually do videos in the presentations, but what you'll see is you'll see routes phasing in and out. They'll go blue and they'll go black, and they'll go blue and they'll go black, because what's happening is it thinks it's got routes, and the routes are good, and then it processes them, and then it looks at it and says, oh, wait a minute, this is for me. I'm not going to use this. I'm going to send it out. And it's going to go through that process over and over and over. So this is a really tricky one that you've got to make sure you pay attention to. And the other thing that we haven't seen yet is that the default log is not going to display this message. You have to add the OSPF action memory to be able to see this message, which is the equivalent of, if you look at the debug level here, this is your standard syslog facility levels. This is your highest level of information, which is debug level. That's what that actually does in the log. And you're not going to see that until you enable that. So I highly recommend, if you're using OSPF, using BGP, if you're using a routing protocol, make sure that when you're troubleshooting that you're enabling those different topics inside RouterOS so that you can see this detailed information. Because a lot of times, people will come to us and say, man, OSPF is just blowing up and I have no idea why. And if you look at the logs, a lot of times you really can reconstruct like what is actually going on if you pay attention to the logs and you know what these messages mean, and you can figure out what's going on. So same thing on the other side. We're going to look at router 4, and router 4 has the same problem. It's receiving, it's the true .4, and it's receiving an update of a self-originating LSA, so it's seeing routes coming in from itself that it doesn't recognize. So it's trying to put them in the table, and then it's deleting the LSAs, and it's saying, I'm going to delete that because it looks like it's from myself, and I shouldn't be getting that. Okay, let's take a look at IPv6 for a couple scenarios and see the similarities and differences with IPv6 and IPv4. So the first one we're going to look at is a hello timer mismatch. Now, if you remember, we did this in IPv4, so very, very similar to the way it's done in IPv4, only this time we're going to look at 2001:DB8:128:126. I used 126 specifically because 126 is what most ISPs use as a transit subnet in IPv6. The reason they do that and not a /64 is because there's too much of a potential to DDoS a /64 if somebody comes in and is trying to hit IPs, because there's like, gazillion of them. So a /126 only gives you 4 usable addresses out of the subnet, and it's kind of the equivalent of a /30 in the IPv4 world. So let's take a look at the hello timer mismatch. Very similar, except if you notice now we're under OSPF v3 interface. And we're going to add area backbone and hello interval 20 seconds to ether 1. No interface config, same as before. It's default in this scenario. And we're going to look at routing OSPF v3 interface, print details. And we've got a hello interval of 20 seconds here, and we've got a hello interval of 10 seconds here. Almost the same as IPv4. So a lot of times IPv6 feels like it's scary and it's different. It's really not that different when it comes to the mechanics of OSPF. It's almost identical. The main difference, and we're going to look at it here, is in IPv6, you're not using the subnet that you're putting on the link to form the adjacency. IPv6 uses what's called link local addresses, non-routable addresses that are designed for the routers to communicate with each other, and that's what this FE8::: is. If you remember, let me back up for just a second and see the actual address on the link is 2001:DB8. But if we go forward to what the log's telling us, you'll see it's FE8:00, and that's because it uses an entirely different kind of network address underneath the network that you put on top of it. So this is a slight change here. Your source is going to be a link local instead of a globally routable address. Now, one of the things that makes more challenging for is finding that link local address, because in the case of OSPF, that was a globally routable address in the source, and you could kind of use that as a piece of information to hunt that down. Here, it's not the case. Link local is just that. It is local to that router, so it's a little bit harder if you have this log message coming in to derive where this problem is happening. So let's look at area mismatch. And I chose area mismatch for a very specific reason. Same network, same 2 routers. And that's because one of the things that's different about IPv6 is in IPv4, OSPF version 2, you use network statements to form adjacencies. You don't do that in IPv6, and that's true across all network vendors. IPv6 only uses the interface. So whatever prefixes are on that interface, which you can have more than one of, it's going to use in its OSPF adjacency. It's going to use the link local. So here we put it into area backbone under the interface, and if you remember when we did this in B4, this was under a network statement. Now it's under an interface statement. So we put it in backbone, And here we've added it to area 51 v6. And the notation of the areas doesn't change in v6. It actually is a dotted decimal notation. So the area part of it is still 0.0.0. whatever. That part doesn't change for v6. So let's go into here and look at the backbone. So we see we've got backbones correct here, but we're in a mismatched area here, and that is incorrect. And same kind of deal here. You've got the discarding packet because we have an invalid area. If you remember, v4 was the exact same way. And then you've got a source of a linked local address up here for IPv6. Now, one thing that you need to note is that in this scenario in IPv4, the normal logging would show this problem in your router. In v6, you have to have the extra OSPF logging action that I mentioned for the previous condition enabled if you want to see this message. It doesn't come up under informational, it comes up under debug. So that's a slight difference between the two, same action that you need to be aware of. And then this right here is just a table. It's a little small, and this is really meant for you guys to go back and take a look at it. If you're trying to do an adjacency with OSPF with another vendor, and I'm going to use Cisco in this example because we commonly will do that, you'll see these are the commands. I've put all the corresponding commands for show commands in Cisco versus the routing commands in MikroTik, as well as a very basic config. So if you need to go cross-vendor, this is what it would look like, the commands that you'd use to troubleshoot and configure OSPF between two different vendors. All right, and finally, I'm going to talk about just a couple scenarios that you need to look for when you're troubleshooting OSPF, and a few known bugs in RouterOS. One I found out about last week in Germany. We were at MUM Europe, and I was talking with Maris, who does routing for MikroTik, and something very interesting came up that we were talking about is an issue that they're working to correct in the next generation of routing engine. But first, some of the things that we see as consultants as we're working with different networks, these are some very common scenarios that cause OSPF to go down that are outside of some of the things that we just talked about. Firewall rules blocking the multicast for OSPF, that can cause OSPF to go down, and you won't know it until you go check your filter rules. Packet loss can cause the neighbors to drop. Something you've got to make sure that when you're troubleshooting OSPF, make sure that you don't have heavy packet loss that exceeds the hello and dead timer, because you may ping it and it pings fine for 60 seconds and everything looks good, but leave that ping running for maybe 30 minutes and you might discover that you have a chunk of packet loss that exceeds the OSPF dead timer, and so OSPF goes up and down because you have packet loss. High CPU can also cause OSPF to drop. If you've got something driving the CPU of the router up, that can cause OSPF to tank. And you may catch a bug that causes a problem with OSPF, and that's where packet captures can be very helpful in understanding what's happening between the two routers, because you can see bugs usually manifest themselves in packet captures. So let's talk about a few OSPF bugs that are known in RouterOS that you may come across. There's a problem with MD5 authentication right now. MD5 authentication, there is an issue in the way it resequences LSAs. So if you turn MD5 authentication on, you're going to have a problem. It may be stable for 5 days, and then it may start hiccuping because of the way sequencing is done. OSPF v3, a lot of people know about this one. Recursive routing doesn't work in OSPF v3. What recursive routing is, for those of you that are not familiar with it, is if I want to advertise a loopback into OSPF and then use that for BGP peering, the route for BGP is going to be recursive, meaning that it's not a directly connected subnet as the next hop. It is a route to somewhere else, and it's got to do 2 route lookups to get to the next hop. That works in v2. It does not work in v3. And then this one was really interesting that we learned last week, that OSPF v2 and RouterOS implementation can only carry 120 LSAs before it breaks. And the reason that's a problem is there is a fragmentation bug in the routing kernel that means that it will not carry more than 120 LSAs. So in other network vendors, when LSAs exceed 120, it's going to continue to add packets to the OSPF sequence in the database exchange until it sends all of the LSAs that it knows about to the other router, and it will fragment that data across multiple packets. In RouterOS, there's a bug that it can't fragment that across multiple packets, so in a 1,500 byte packet, 120 LSAs is the maximum you can get. Now you can mitigate that by doing jumbo, but that still only gets you so far, and that's something that they have planned to fix in the next generation routing engine. So if you have a really large network and you have a lot of LSAs and you've had some weird issues with OSPF, that would be something that I would start doing some packet captures and see if you're hitting that 120 LSA maximum. I don't know the details of it. I discussed it with them, and I don't know what conditions cause it to appear. They just said that if, and it may just be if the LSAs fit cleanly into each packet, that it's okay. So I would definitely ask MikroTik for more details on that, because we just found out about it last week, and I'm going to try to replicate it in my lab to see under what conditions it exists. I know they told me in that specific scenario they raised the MTU to 9,000 for the customer as a workaround, and that helped. So I don't know. It's a new one. Okay, so we covered a lot of material, and I'd like to go ahead and open it up to questions, if any of you have it on OSPF troubleshooting.
Can you go? Oh, sure. Maybe it's too specific. Tell me if it is. Is that okay? Okay. I was just wondering if you're familiar with the error discarding packet locally. One of the things that I've seen, like, intermittently, doesn't seem to, like, I respond, I Google the forums, and see the forums, talking about it, I never got a clear answer. I don't know what causes it.
Yeah, I've seen that before. Normally, my recommendation in those scenarios is we normally don't see that when we're within MikroTik to MikroTik, and we're on the same version. So one of the things that I will see a lot of times in MikroTik is when you're using different versions across all of your routers, you can have some weird interactions happen. So I can say that when it's properly configured and you have your MikroTik to MikroTik and you're using the exact same code version that's known to be stable, I don't normally see that issue. I've heard of some people.
It's all the same router versions, and it's all MikroTik to MikroTik.
Have you guys done a packet capture on it?
Yeah, and I didn't really learn anything. I didn't learn anything.
So, like, yeah, I'd be interested to look at the database exchange. I'd be interested to look at the OSPF database exchange and see, like, actually decode the hex of the OSPF database exchange and see what it is that's happening between those two that makes it think that there is, an issue with locally originated.
Cool.
That would be the thing to look at to see, because once you look at the database exchange and the way OSPF is exchanging that data, that's where you start to see bugs come out.
Okay, cool. Thank you.
Yep.
Do you have more questions?
Question down here.
Sorry, wait for Mike.
Thank you. Hi, and thank you. Lately, we've been noticing like two-way initiation packets and two-way down packets. It'll resolve itself, but we've been seeing it more and more lately, and I don't know if you had any ideas about that.
If you're saying you're going to two-way and it's getting stuck?
Right, it'll go to initiate and then say, hi, how are you, to act. So it's the agencies between our neighbors on our routers. But it'll do it periodically.
So what I normally, when I do this for my clients, what I normally do in a scenario like that is I will set up a packet capture on the router that will be only for OSPF. So I'll target to the OSPF protocol and just that interface and give it a really, really large file size so that I can let it run for like a week or so. And then correspondingly, I will also set up like an ICMP test through that path and leave it running for a week. And then what will happen is when it hiccups, I'm going to go back and I'm going to pull that packet capture at that exact point in time, and I'm going to pull that ICMP test at that exact point in time to first verify there's no packet loss on the link that's causing that to happen. And then you also in the packet capture can see if you have like an MTU problem that's causing you to go two-way, you're going to see the packet size and the MTU capture show that maybe you're 1480 on this side, but you're 1420 on this side, because maybe a radio is going nuts and it's causing you to lose MTU in your packet transmission. So packet captures and ICMP done at the exact same time on a problem link will often bear out like those kinds of issues, because you're either going to see packet loss that you didn't know you had, or you're going to see some anomaly in the packet capture that you can't see in the normal debugging.
All right, thank you.
Yeah, sure.
I don't know whether this is something that's in OSPF or maybe there's another way around it. We have OSPF running on some backhauls, and all of a sudden, for whatever reason, one of the backhauls goes really bad and goes down to maybe 1 meg throughput or 5 meg throughput or whatever. Of course, OSPF is still happy as a lark, but nothing's working. Is there some way to dynamically look at links and say that's a bad link, no, we don't want to use that anymore, because the OSPF doesn't go out until the link is totally gone?
Right. So you've got like just a little bit of throughput, and you modulate it down, or whatever the case may be. So I've seen some interesting work by Juniper on that, and some other people on getting a controller to actually query the path and look at the path, and then do SNMP queries of the radios, so that you can actually see what the modulation level is. And so if you look out on the internet, I've seen some people do some scripts where they're going to do an SNMP poll of what the modulation of that radio is, and if everything goes way, way down, they will have a script that actually will either disable that path in OSPF, or it will change some attributes in OSPF to make it a less preferred path. So it's still active, but it will change the cost to flip it to the other path. In some other implementations, it's called dynamic QoS, is what they call it, so that you can flip traffic back and forth, but it does involve a fair amount of orchestration, coordination, and work to make that happen. So it is possible to do that, but there's nothing off the shelf that's going to let you do that, that's built into the protocol, that you can easily react to that condition. So it's possible, but it takes some work.
More questions?
Okay, cool. Well, thank you very much. I appreciate it.